Hello guys, my name is Dharyll from Batangas State University, and for today's video, I'm going to share to you or tackle a brief summary and an overview of the chapter 9 in the NetAcad. So previously, I've already made the full summary of the chapter 9 in the NetAcad. So in this video, I'm just going to discuss brief summary and overview of what's on what are the going to what are the topics or that will going to be discussed here in the chapter 9 in the NetAcad. So without further ado, let's get started. So in the chapter 9, we will be able here to explain on how transport layer protocols and services support the communications across the data networks. So we will also here be able to explain the purpose of the transport layer in managing the transport data in an end-to-end communication. So we'll able also here to explain the characteristics of the TCP and the UDP protocols, including the ports number and their uses. And we'll also here able to compare the operations of the transport layer protocols in supporting the end-to-end communications. We will also be able here to compare the operations of the transport layer protocols in supporting the end-to-end communications, explain on how the TCP session established and terminate and the termination process of facilitate reliable communication. We'll be also able to explain how the TCP protocols data units are transmitted and acknowledged to guarantee delivery. And we will also be able here to describe the, the UDP client processes to establish the communication with the server. And next is we, of course, we in this chapter we also have to determine whether the high reliability TCP transmissions or non-guarantee UDP transmissions are best suited for the common applications. So, so basically in the chapter 9, it will begin in the overview of the purpose of the Cisco iOS access list. So, and their own role in filtering the network traffic, and this may include a look at the order in which access lists are evaluated and the different types of access lists that exist. For example, is the standard and the extended, and as well as the different uh, ways in which access lists are applied to router interfaces. So in bound and outbound, the implicit deny all statement at the end of every access list was also discussed, and a look at the standard IP access list outline their liability, or rather their ability uh, to filter traffic based on the source of the IP address of the packet. So The access list command was introduced for the purpose of adding the entries to an access list. So as was the access group command, which is used for to standard and extended access list to an interface, and a look at wildcard masking explained on how groups of uh, computers could be specified within access list. So an overview of extended IP access list specified within a access a more uh, granular level on filtering control that this access list provide by source and destination IP address. So as well as by the protocol and port number, the liability to monitor IP access list was examined by looking at the command used to view all uh, lists defined on the router, as well as those applied to interfaces. So in this chapter, it is also tackled here the IPX standards and extended access list were the looked at next. Standard IPX access list can filter traffic by source or destination address, and extended to IPX list provide a finer level of control, allowing traffic to be filtered by protocol socket number if necessary. And an overview of an IPX access list shows how the SAP traffic could be filtered on a router according to the source address, so a service type code, and an even server name. The difference between the input subfilter and the output subfilter is that the command used to apply SAP access is list to interfaces was also discussed, and the UTP datagram and the TCP segments have headers added in front of the data that include a source port numbers and destination port number. So these port numbers enable data to be directed to the correct application running on the destination computer. So the TCP does not pass any data to network until it knows the destination is ready to receive it, and TCP then manage the flow of the data, and it resends any data segments that are not acknowledged as being received at the destination. The TCP uses a mechanism of the handshaking, the timers, and the acknowledgement message, and the dynamic windowing to achieve reliability. So in the reliability process, however, impose overhead on the network in terms of much larger segment of headers and the more network traffic between the source and the destination. So for example, that if the application data needs to be delivered across the network quickly, or if network bandwidth cannot support the overhead or the control messages being exchanged between the source and the destination system. The UDP uh, would be the developer preferred to transport layer protocol provides the UDP provides none of the TCP's reliabilities features. However, this does not necessarily mean that the communication itself is unreliable. There may be some mechanisms in the application layer, protocols and services that process loss or delay datagrams if the application has these requirements. And the application develops or decides the transport layer protocols that uh, best meets the requirements for the applications. So it is important to know, to remember that the other layers all play a part in the data network, and communications and influences its performance. So basically that is all about here in the chapter 9 of in of a brief summary and an overview chapter 9 in the NetHackad. And if you like this video and if you learned something, please leave a like and share. And thank you for watching. Bye bye.